Hello everyone. Now let's work on leetcode 3219, the minimum cost for cutting cake, the version 2. And I actually suggest you read the problem 3218 before solving this question. So all the questions description are identical and all the examples are also identical. And the only difference is the constraint is on the order of 10 to the fifth. So previously it was just 20 numbers. However, this time it's 10 to the fifth. And so that the way we solve in the previous version does not work. Actually, we can go back to the previous question. Let's see. Yeah, this way. Let's see. 3 to 1 8, right? 3 to 1 8. So the way we solve it in this previous version is just record all the intersections in F depending on HC and VC, right? Then we say if Fij is 0, it's vertical first. It's 1, then we cut horizontal first. Then we can use for loop to get the answer. However, in this can work because this number is very small, right? But in this question, now it's on the 10 to the fifth, so that we cannot use this 2D matrix to remember all the values, right? Because it will just out of memory. And also, these for loop are also time consuming. It will over the time limit constraint. Then how to do it? Actually, we can copy this solution to our current version. It's 3219, right? So let's copy it here and see how we get the new solution based on the previous version. Let's read again about this solution. Actually, we find we are adding some cost based on the value of Fij, right? However, it doesn't matter which Fij it is. Okay, so if we know for this I, there are the total number of Fij equals 0 is some value, then the cost is just add to HCI times that value, right? So it's also similar for this one. So if we know for this J and for all the i's from 0 to m minus 2, then the total number of this Fij equals 1 is k. Then the cost is just plus VCJ times k, right? So suppose we can write here. So cost is just VCJ times k, right? If we have k equals 0, then k plus plus. This is a new version. These are identical, right? And now I think we will have a better way to calculate the number of k, right? We do not need to loop over all the values to get k. That is the main observation to solve this harder version. So the way we do that is actually we can sort all the HC and VC. Then we just use binary search to get how many values in VC or HC is greater than some number. Then we directly have this k. Then we can do all the calculation in O n log n time. Let's write the code here. So the first thing is also we make it HC and VC. Then we first sort HC also VC. Okay. Then we have two vectors. F1, it is m minus 1, and we have F2, it is n minus 1 size. They are used to record for each horizontal line total count of intersection, which need vertical first. Similarly, we have for each vertical line, we need to get the total count of intersections, which need horizontal first. Okay, these are these two vectors. Then we need to calculate the actual number here. So how to do that? We first loop over all the horizontal lines. So it's I equals 0, I minus less than m minus 1 plus I. Then C equals to HCI, right? Then we use binary search lower bound to get the position greater or equal to C in this VC. Okay, then F1I is equal to STD distance from VC begin all the way into IT. Then because we are going to get the total count of intersection, we need vertical first, so that we need all the numbers where the vertical cost is greater than the horizontal cost, right? So it is m minus 1 minus this one. Okay, so this is for all the horizontal lines. Then we do similar thing for all the vertical lines. So I will be j, m equal be n, I equal to j. So this is VC j. Okay, so this part is tricky because we are using lower bound here. Lower bound actually means less equal, greater equal than C, right? However, for this part, for those value equal, the HC and VC are equal, it can only belong to either this part or this part, right? So that we only need to get all the numbers larger than C, so that we need to use upper bound here. So this is very tricky. So this is HC and HC, and this is F2J. This is M, and this is HC begin all the way to IT. Okay, so then we have F1 and F2. Then what we do is to do similar things for this part, right? Let's copy all those code here and paste it here. First, we loop over all the horizontal lines. So this is cost. Then it will plus HCI times FI I, right? And actually, yeah, I think that's for this part. And for this part, it is plus VCJ times F2J. right? Then we add it to the res. Let's see if this will work. Okay, these two cases are correct, but we cannot submit now because this is returned as long, so we need to handle this part. So long, and this is long integer. So this is long, and long here. Yeah, let's see. And I also think we miss one condition. So we directly use HC begin here. So which means we suppose there's some value in HC. However, it can be empty, right? So if HC is empty, what we shall do? The minimum cost is just the cost for all the numbers in VC, right? Okay, then if VC is empty, we do the same thing. Okay, so these are two special conditions. Let's submit. Okay, it passed. So we'll delete this part and submit again. Okay, and the time complexity is n log n, I think. Oh, it doesn't work. So anyway, so I think that's it for this problem, and thanks for watching, and see you next time.